joined in from everywhere. Welcome. We're launching a new series called Guruvari. What we're trying to do is, our tagline is, let's learn from the gurus. So what better day than a Guruvar? So we've chosen Thursdays. So Thursdays at 5, we've started a sequence. We will have these 3 lectures starting today. And we will try to get in as many possible topics and interesting people who can broaden our horizons and give us depth in certain subjects we know, but don't necessarily get deeply into. So that's about the series. Then I'll introduce our guests. We have today with us from Saint Gobain Ecophone, 2 eminent people who have done a lot of research, a lot of work in the field, a lot of experience. I'll start by introducing Prateek Tandon. He's a business unit manager at Saint Gobain Ecophone. He's a wealth of industry experience for over 2 decades. And he's been using this, he's been leveraging this to help Ecophone get a base in India, a very strong base. They already have one, and he's growing it further and further. He basically wants to see the brand name Ecophone almost synonymous with acoustic solutions across. And trust me, with the research they're doing, it's helping. Correct? And as he likes to say, it has always been our endeavor to brief and train young minds on the subject of acoustics so as to enable them to provide services to their prospective clients with a sound effect on people. So with this, we welcome Prateek. I will also introduce Manit, and then we'll start with the questions and the presentations. Manit is a concept developer at Saint Gobain. So he also has a decade of experience, mega projects all over, and he does a lot of research. He's very convincing. When he participates in your project, it's not just as a person from a company trying to sell things. He comes, he convinces you, he runs experiments, proves it to you, and then you're sold on it. Correct? He does it just the right way. And as a speaker, he's amazing. A 3-time TED Talk speaker. Correct? We do know what it means. Very popular, very nice. I think I'll leave it at this. They don't need further introduction on this. What I'll do is I'll put my first question to Prateek, and then we will take on with Manit what very little that we know about sound. We talk about good, bad, and disturbing sound and others, but we are not technical about it. They're going to tell us what is sound, what it means, what are the technical terms, and how to attenuate it to make it good for you. They're the masters at this. Let's learn. So to start with, I would like to ask Prateek. Prateek, can you tell us a little brief, a very short brief about what is Saint Gobain Ecophone?
Mr. Jana, first of all, thank you so much for this wonderful introduction. I sincerely appreciate your gesture, and thank you so much for having me and Manit in this inaugural session of Guruvari. It's wonderful to be here, and I'm sure it's going to be a wonderful session talking to the eminent staff, faculty, and the young audience. Let's talk about Ecophone first before we move ahead. Ecophone is a Swedish company. It's a part of Saint Gobain Group, and Ecophone develops, manufactures, and market acoustic systems and solution for its wide range of products that primarily comprises of the ceiling systems. We are talking about the grid ceiling systems, wall paneling, free hanging units. We call them solos. These are the independent panels, and the ceilings which can be directly glued onto the soffit. So these are the main 4 categories of product family we're talking about. But the whole thing about, as you mentioned, Ecophone is all about acoustics. So it's been 60 years since Ecophone has been into existence, and It was the year 2009. We started our business in India. So it's been 11 years for us in India. Ecophone has been our it is a part of Saint-Gobain Group, as I mentioned, and we have our business interests spread all across the globe, starting from Europe, which is the birthplace, to North America, Brazil in South America. We have an entire Asia covered by us, Pacific, Russia. We have about 800 employees working for a common agenda and common passion, and that is acoustics. So this is just a brief about Ecophone. And as we move along the session, we'll have more discussion on what Ecophone is all about, what acoustics is all about, and what we have been doing in India market for last 11 years.
Right. Manit, what I would do is want to get into acoustics.
Yes, sure.
I want myself and my students to start understanding what is this.
Sure.
So what I would say, if you can take us through the basics of what is sound, a little deeper understanding so we know some terminology, something about room acoustics.
Sure.
And what I want to especially know is the critical challenges that we come across in different types of buildings.
Sure, definitely. So good evening from my end to everyone once again. Namaskar. And it's been a great opportunity for us to come back to campuses and interact with the students. And thank you, Shantanu sir, for giving us this opportunity. It's a great pleasure to present our ideas and experience so far in the industry and to talk a little bit about acoustics. And as you mentioned, I think while we're doing this session, I think the only agenda that we should take this up, and what I have in my mind is to ensure that we build some familiarity with students about the subject of acoustics. I think that's the only agenda. At the end of our discussions, if they are able to comfortably deal with acoustics as a subject in their existing project works, and when in future they start practicing themselves, I think that's the main task in our hands today. So of course we'll be happy if they remember Saint-Gobain and Ecophone, but I would say we'll be much more delighted if they remember to prioritize acoustics. So that is the main crux for the session that we have planned for today's session. I will quickly first put up the presentation on screen, and then we can discuss some of the basic aspects. Is it fine?
Sure.
Yeah. Just give me a second. Great. I hope the screen and my voice both are clear.
Yeah.
Great.
Yes.
So once again, welcoming everyone to this session. And before we get on to really the basics, I thought it'll be great to put forward a question. Okay, we need not take answers directly from everyone, but it's just something to ponder over. What do you think is a good working environment or acoustically good environment? To my understanding, it is something like this, isn't it? Nice, peaceful in the outdoor settings, where probably the only things that you are hearing is bird chirping noise or the sound of air over the grazing fields. It's very comfortable, extremely idealistic, I would say. But what often happens and what we end up is in closed indoor spaces, and sometimes I'm sorry if that's been a little harsh and loud on you. That was just a quick glimpse of how acoustically chaotic situations can become. This is not a computer generated image. I believe it's a live photograph taken sometime earlier. It seems to be a call center, I guess. I'm not even sure how somebody goes and sits into the middle. But I think apart from the space crunch, what I want your attention to is to understand that how acoustics is going to be an important element in these kinds of spaces. When the per square foot space available for an employee in an office environment today is shrinking year by year, we are going to face increasingly the challenges on acoustics. The way it affects the productivity of people and the way it can affect the output for these organizations. So a little bit more on the basics of dealing with sound. As you already would know, when we're sitting on an outdoor setting and talking to someone, as you see here on screen, sound will go on all directions, correct? it doesn't really bother you with any unnatural reflections. But moment we are made to sit inside confined spaces into a building interior room, what really might happen are these red lines, or what we might want to call them as the unwanted sound. So for any acoustic treatment that one is going for in building interior scapes, I would say ideally this is what is done. This is what happens. We want the direct sound waves, and we always want to eliminate through an acoustic treatment sound waves which are not required in that space, right? And when we wish to do so, we have different surfaces, different substrates which can assist us, which can help us out. And just as an example, if you have a sound absorbing ceiling, just as an instance, what will happen with that? If there is an incident sound energy, some of it will be absorbed within the material. Some of it might be transmitted above if there is a wide space behind the ceiling. And of course, some of it might also get reflected. So this way, every surface, every material that we see in the interior spaces around us has something called an alpha absorption coefficient of sound. Okay, it's designated as an alpha value, which is the sound absorption coefficient for any material. And it's a simple formula which is absorbed plus transmitted upon incident energy to find out what is the capacity of the material to hold back sound within. Okay. Now, while we're trying to understand the basics of sound, I thought it'll be first interesting to talk to you about how do we deal and measure sound. So there are two aspects to it once again. First is frequencies of sound, which is the number of oscillations of a sound wave. So I'm taking you back to little physics and the behavior of sound. And here I would like to play certain sound files and bring a little closer perspective towards understanding of frequencies. First, I'm just playing 2000 hertz sound. I hope you're able to hear it clearly. This is 2000 hertz. 1000 hertz. 500. Now we can really test my laptop speaker output and your headphones all together. So this is 250 hertz. I hope you're able to hear it. I think it plays well in my earphone. Let's try for 125. I'm hoping you are able to hear something out of it. It's 125 hertz. Challenge could be with 63, but let's try. And I've missed out 4000, which is a screechy sound. Apologies for that. But this is just to give you perspective as to how do we hear different frequencies as per our human hearing scale. That's something which I wanted to just bring onto the table. So why are we discussing this is because this is one way of understanding which sounds are prevalent or dominant in a given room. So what I mean to say is right now when I'm speaking to all of you, if my sound is approximately 700 to 800 hertz in terms of the frequencies, and if that is going to be a dominant frequency in a particular room or a space, you need materials which can work efficiently in those frequency points. Another example, if you have a kindergarten school or a classroom, assuming a female teacher is going to take lectures the whole day, usually the sounds from a female's perspective are higher. The frequencies are easily around 1500 to 1600 hertz. And so is the case with young children around. And what I mean to say is in that case, you need to pick and choose a material which performs the best in those higher frequencies and not the lower ones. Another quick example here, and I love to quote this every time, and especially in front of students. I'm sure most of you have seen Jurassic Park movie. Yeah, and I'm assuming it's a yes. And I'm talking about the first part, the first Jurassic Park that came out, right? You remember that scene when those two children, they are inside the huge building and there's a dinosaur which comes right behind outside the building premises, and the jelly starts shaking in the child's hand. Do you recollect that scene? Now that's something which is, where the sound is getting emitted at very low frequencies, but very high decibels. The sound is getting emitted at very high decibels, but very low frequencies. And that is something which we are not able to probably hear as such, but we even start feeling the vibrations of sound. I'm just trying to give you examples to help you relate. So that's the scale that exists as per our human hearing capacities. So this is one aspect of dealing with sound and understanding sound in detail. And the other aspect, which I'm sure we are all well versed with is called decibels. So do you think it's similar to frequencies or is it different? It's different because here we are not talking about just the number of oscillations per second, but here we are talking about the net energy that the sound wave is carrying. The intensity of sound is measured through the dB levels. So it's a different form of measurement. And once again, here I would like to quote an example and explain this to you. Imagine, as you see in the photograph here, somebody who is really loud screaming over phone, and that sound level is say 80 decibels. And if there are two people in that same room talking at the same intensity of sound, the measured sound in that room is not going to be 80 plus 80 as 160. It's going to be 83 decibels. And what we're trying to show here is the simple nature of sound, as it's not measured in a linear scale as 80 plus 80 is as 160. It's measured in logarithmic form. So if you do the log calculations for two equal sound energies of 80 decibels, you will get the final output as 83 dB. Now, why this piece of information is really important for all of us to note today in the discussion is because this is true for all kinds of sound sources. Right now, just as an assumption, I'm speaking to all of you at say 65 dB, assuming that's my sound throw right now. And if somebody else is also speaking at the same time at 65, the measured sound in this room will be 68 decibels. Two equal sound sources, the net difference is always going to be plus or minus 3 dB. Now, how this is important is, say, for example, if you've been designing a room for a 2-seater application, and if that has to be expanded tomorrow for a 4-seater room, do you think you'll need to be worried about the acoustics and what kind of disturbance it might, or what kind of sound levels that might happen inside? It's just going to be a difference of 3 decibels. So 3 dB is what is going to be increased in that room from a 2-seater to a 4-seater. I'm always talking about doubling of sound at equal intensities. So likewise, when you have these two gentlemen speaking at the same sound level, if you add 2 more, it's always about equal sound energy, you will get 86. To those 4, you add 4 more, as I said, equal sound sources, you will get then 89 as the answer. So likewise, if you have 10 equal sounds of that nature, you will not get it as 800, of course. It will be 90 decibels of sound. So this is just a small attempt from my end to explain to you how do we deal with sound in terms of the measurements. Either it is through the frequencies and understanding of what frequencies are dominant in that room, depending upon which you choose a particular surface treatment, or you decide through the decibel measurement as to how many dBs are you worried about. So is it going to exceed the benchmarks and the standards which are laid as per the ISO norms or international norms, ASTM standards, etc. And you do a certain acoustic treatment to bring down the dB levels in that room. I'll add another element of complexity to these discussions before we talk about the challenges that we face in various types of buildings. When we reduce sound pressure level by 10 dB, what really happens? Okay, now I'm talking about not the theoretical part, but our human experience of sound. So when I said my sound right now is 65 dB, if I reduce my sound and speak to you at 55 decibels, essentially you will start hearing it as half the intensity of sound. This is true for all kinds of sound sources every time. 10 dB reduction, psychologically, we start feeling it as half the loudness. And the converse is also true. 10 dB increase, we will feel it as double the intensity as per our psychological aspects. That's all about the physics and theory part that I really wanted to talk to you about. But broadly, when we consider acoustic treatment for different types of spaces, we split our discussions usually into 2 broad segments. And that's why on the screen, these are really kept a little far away from each other because they're 2 different terminologies. Insulation is when you're trying to protect sound transfer from one room to the other. So it's essentially to do with the partition system. It could be a glass partition or a gypsum drywall partition or a conventional brick wall. That is to take care of the insulation, room to room noise transfer. Absorption is the phenomena that we usually discuss about within the room acoustics criteria. Okay, so when you need to avoid echo problems, when you need to ensure there is lower noise level, when you need better speech clarity to be able to listen to each other clearly and not have a highly reverberating scenario, there we are talking about absorption as a challenge. A little bit more on absorption part. Some of you might have heard a term called NRC, which is noise reduction coefficient. It's an ASTM standard, which basically means what is the capacity of a material to absorb sound. And as you see here on screen, it's a simple lab test result where we emit sound at different frequencies in the lab and test what is the percentage absorption that you get here. And we draw a simple average between 250, 500, 1000, and 2000, these 4 frequency points. And we draw a simple average and check the alpha absorption. If you get 0.7, the NRC is 0.7. If you get 0.9, you get 0.9 as the answer. I'm sure there is one doubt which might be coming into some minds, which is when it's a simple average, how do you know when you have 2 products with the same NRC value of 0.9, are they going to perform the same way and provide the same results at site? Maybe not, because as you're rightly thinking up, there could be one product which performs the best at 250 and 500 hertz, but the other one is doing better job at 1000 and 2000 hertz. Because it's just a simple average method, on paper, you're still getting as 0.9 NRC as the value. And that's the reason why the European standard and the benchmark, which came a little later, was found to be better useful. So EN ISO 11654 is a great standard to adhere to for building interior scapes, where we are classifying materials basis the absorption class value, split into 5 different bands. So when you know that you have chosen a class A material for your project, the performance is only going to be in the blue band for all the frequency points. If you have chosen class C, you will know that the performance is only going to lie in the yellow band that you see in the middle. So that's a better standard and a better way to pick and choose the right materials for your projects. And obviously, higher the NRC or higher the absorption class, the better output you would get as far as the acoustics is concerned. To give you a little more perspective about the other materials that are used in building interiors, something like a parquet floor or a hard flooring, a brick wall almost has no NRC value because, as we discussed earlier, it's to do with providing sound insulation. A window glass is an interesting case because it does absorb some sound energy in the lower frequencies, but then it drops down. And reverse is the case for a soft carpet that we often come across, like a 10 mm thick carpet. Almost no absorption in the lower frequencies, slightly higher in the upper ones. But none of these are as close to the best in class standard, which is class A sound absorption. So many a times, by just depending on curtains or carpets and vanishing blinds, it may not give you the results that are required, say for example, for an office or a classroom or for a healthcare facility. In a nutshell, I would like to say that these 4 points are very crucial for us to understand what is the material that we are using, what is the surface finish, whether it allows sound penetration, the thickness of the material, thicker the material, better is the sound absorption, and the overall depth of the system, which is the distance between the false ceiling and the air gap behind. Okay, so right from the soffit, what is the overall depth that you get? That is also very crucial for enhancing the performance. Now, I would like to take back to some of the students who are possibly from the 3rd year and above. You might have come across a term called reverberation time. Okay, so I'll just try and explain that in a audio way. This is a short reverberation sound. And the same sound, if it was highly echoing and reverberating, it sounds like this. Just before beginning this session, we were talking about the treatments in churches, and when the choir is being played out, what is the net effect of acoustics and things like that. This is just a quick demo to show it to you that what is short and long reverberation sound. And logically, shorter the reverberation in a working environment. Now I'll not talk about churches really, but shorter the reverberation in a working environment, like an office, once again, an education institution or a shopping mall or a healthcare facility, the better it is because you are not disturbed with the long reverberating effect and it's not bothering you in terms of prolonged echoes and noise and disturbances. Usually for building interior spaces, we talk about these 4 terms quite in length. So I would just quickly in a nutshell try and present that to you. Reverberation is what we have just discussed, which is closely linked to speech clarity. Speech clarity is when you have high echo problems and you are actually missing the clarity of what is being spoken. The second word reaches you before the first word has ended. So that is the second term usually applied, and where you would need to provide a certain acoustic treatment. So reverberation and clarity of speech improvement is often the second challenge that we come across in building interiors. The third is sound pressure level, which is to do with, say, a noisy and chaotic place like a canteen, a school canteen. Recollect your days. I'm sure there's a huge canteen space in your university. I'm not really sure acoustical treatments of the space, but if it is not, I'm just assuming that, and apologies if I'm completely wrong with it, but if it is acoustically not well treated, and if all the chairs are completely occupied, it becomes highly chaotic for sure. And it used to be the case, I remember in our office canteen just a few years ago. I think our office got renovated about 4 years from now, and it used to be not really comfortable. The only reason behind that is there are not enough materials and substrates which are taking away the excess sound energy. Now with lots of these ideas and solutions that Ecophone brings in, I think what I know for sure is almost all the Saint-Gobain offices in India have good acoustic conditions maintained. And of course, we've been providing these services to many corporations, and not just in the office environment, but also in the education sector. So ensuring lower sound level and background noise is another different type of challenge. As you see, it's different from reverberation. It's different than speech clarity as well. And the fourth one is called sound spread or sound propagation, which is something which is again peculiar to office spaces, which is about spread of sound from one point to the other. 2 or 3 people talking and chit-chatting in an office area can potentially disturb many others in the office because of the open office design these days. So spread of sound control could be another very important challenge to manage. So some of the crucial points that we've been discussing so far, the size, shapes, surfaces, and furnishings are very important. More absorption gives lower sound pressure level, that is given. And reverberation time is not the only thing that one needs to look at. There are other 3 parameters which we discussed are very important. And of course, it has to be a combination of the number of people, the room dimensions, and what is the activity that is going to happen in that space. But in these cases, I would still say that to create room acoustic comfort, choosing a class A sound absorber is often an efficient solution because it gives you the right performance in all those 4 parameters that we've just discussed. A little bit more on insulation before we take on, I think, quickly the next 2 questions. When the insulation is less than 35 decibels for a given space, usually you will be able to hear conversations on the other side very easily. Above 35, only loud voices will be understood. If the insulation system is designed for 44 dB protection, okay, even you would not be able to hear conversations for sure. Only loud voices will be heard. 48 and above, only when you place your ear against the wall, it's only then maybe you will be able to hear some things. And the best in standards for interior applications here is usually a wall which is designed for 52 dB of sound insulation, which is where you get good privacy. All right. So the net effect is either you would be disturbed, or you'll be able to concentrate just a bit, or achieve decent privacy at 44 and above. But if you see, for a working office scenario, the main idea behind any acoustics treatment is to support both communication and concentration when it is required. And that's the core idea behind any type of acoustic treatment that we talk about. With schools institutions, the scenario I would say is not so different. So today we see that many classrooms, we find that the sound levels are higher. It's difficult to hear speech clearly. It's difficult to concentrate sometimes. And talking about teachers and professors, I think Shantanu sir will definitely agree with me. It leaves a lot of strain on your voices, conducting lectures the whole day. And that is something which definitely can be avoided with better acoustic conditions around. There are lots of studies which talk about how the hearing capacity from a front bencher to the last bencher changes altogether with good acoustics and not having better acoustic conditions. There's another study which I thought it will be good to talk about during this session is something which was done at University of Bremen, where they studied the sound pressure levels across the day, which was ranging from 75 decibels to 80 decibels towards the end of the class. And what they found here when they measured the teacher heart rate at the same time. They measured the teacher heartbeats during the same class, and they found a near correlation to the sound levels that were existing in the classroom scenario. So this shows that higher the noise, higher is the stress level that is likely to be with the professor and the teacher conducting the classes. And this is something which is very evidently talking about ensuring better acoustics so that the stress levels are maintained and you are still able to productively conduct the classes and ensure better results and better outcomes. Similar is the case, I would say, when we talk about healthcare industry, not just here in India, but elsewhere in the world as well. Typically, what do we hear in hospitals? We often come across sounds like medical tech equipment noise, communication.
Dr. Brantley, 2744. Dr. Brantley.
I'll just cut that sound out. So these are few, irritating sounds which, by better acoustic treatment, one can certainly justify the net existence and the purpose why a school building exists or why a healthcare facility exists, and then try and devise the right solutions around it. So I think that is something which I really wanted to talk about in terms of the basic acoustics and various applications across segments.
Yes, Manit,
yeah,
a nice run through terminology, a bit of application, a little heavy, but it'll sink in.
I hope so.
But in the meanwhile, what I would like is, you did a lot of experiments across India. You must have come across funny situations or difficult situations or situations that do not have standard answers.
Yeah, yes.
Correct.
True. Yeah.
Can you actually share some of those cases and how you solved them?
Sure.
As a concept designer, that is your primary gain, and let's gain out of it.
Sure, absolutely. So I have, in fact, collated certain interesting case studies to present it today. I'll just put that up as well. Just before that, so we've discussed about certain basics of acoustics, how it affects us, what are the challenges that we faced across different segments. So talking about bad acoustics now, if acoustics is not really taken care of, what really happens? You lose time, you lose performance, you lose people well-being aspects. So there's something called recalibration time, where you take a certain amount of time to go back to the same level of engagement that you had while you were working. Moment you have a distraction or a disturbance. You talk about stress levels. There are various studies which really talk about all these aspects. One of them which really catches my attention always is something which was done at University of California, where they found that with two different examples of a noisy space and a well-controlled environment, people were much more efficient, and in a noisy condition, in fact, the accuracy level of performance was getting dipped as high as 50%. So this is very alarming. This is threatening really to an extent that good acoustics in indoor spaces is absolutely essential for people to be good at what they do and produce results at the accuracy and speed that today's worlds are demanding. And that's one of the elements which is very crucial as far as the physical aspects of comfort is concerned for indoor applications. Talking about case studies, since you mentioned, there's something that we did earlier for a space which was like an informal meeting room, sometimes also used as an informal dining area, and where it was extremely difficult to talk to each other because it was all reflective surfaces around. And what we were fortunate to do here as a study was get first the ceiling treatment done, and then one of the walls through an ecophone solution. And what we found out, as now we all are well conversant with reverberation times and the other parameters, what we found is before acoustic treatment, it was 2.25 seconds of RT value measured at 500,000 hertz of sound, which means at the speech frequencies, I would say, which means at the speech frequencies, whenever somebody is having a conversation, that sound was remaining in that room for 2.25 seconds, which is very high, not really ideal as per standards. And the Indian codes usually talk about such rooms should have around 0.8 to 1 seconds, not more than that. When we did the first treatment of ceilings, which was a class A ceiling solution provided, we actually got the RT levels to 1 second rather. And after adding the wall panel solution, which was just one of the walls, we already achieved 0.75 as the measured sound. So here there was an acoustic consultant who was whose services were availed, and they did the actual measurements at site. And it's a very interesting case for us to present every time, that how simple ceiling treatment and just one of the walls, in fact, can bring in a lot of change in the way we are able to communicate and talk to each other. Another very interesting study which we did for a large IT company based in Bangalore for their Chennai campus, where there was a huge cafeteria and we had troubles there about the overall background noise, which was 88 decibels. And with just 60% of the coverage with one of our ceiling products, we were able to bring it down from 88.7 to 78.6, roughly a 10 dB reduction. And I'm sure all of you now would know, what does 10 dB reduction imply? It means half the intensity of sound. And the people who were actually dining there earlier, and the kitchen staff and the people who serve food, etc., we interviewed them later. We found a much perceived comfort to them. 78, I would say, is still higher. It could have been lowered further with higher percentage coverage. But because of certain design ideas, we were allowed to touch only 60% of the space. But nevertheless, we brought half the sound levels and the perceived comfort was much better. And we ended up doing many more cafeterias for the same client later on. In fact, we also ventured for their office spaces later on. From cafeterias, we went on to the open office areas, providing them solutions from grid ceilings to clouds and baffles and multi solutions that we have been providing with lots of these design ideas. Sometimes it's to do with ceiling, sometimes wall treatments help, or sometimes it's the furniture itself. So if you have a highly sound absorbing furniture, that can really provide a great solution, and you can achieve better acoustic conditions in the entire office space. So what happens with every acoustical screen, the overall sound levels in the office go on dipping down, and you actually can get a much better output than you would expect otherwise. If ceilings are not helping, you can always complement them with wall paneling. So this is one of the EcoPhone wall paneling systems, which comes with a wide array of choices for the fabric finish. We can even do printing over these panels, both on ceilings and walls as well. Any graphic design, logos, colors can be actually done on the EcoPhone ceilings and wall solutions. So with these cases, I would really like to say kind of a summary note that the key steps that are involved in a good sound design, for just as an example for an office, is to first identify what are the main challenges in your project. So is it to do with sound insulation or absorption? So first, prioritization needs to be done that way. Then assign the relevant parameters as to when it is absorption, if it's related to reverberation, is it just decibel level reduction? What is the main criteria that we're trying to resolve? And if it's an office, something like minimizing disturbance and spread of sound from one point to the other has to be the main challenge. So likewise, we can actually break around the requirements and aspects of sound and acoustics for every space in the office, and then try and devise the right solution depending upon, as we discussed earlier, the number of people, the room dimensions, and the activity that is going to happen. So what I really mean to say is a traditional office which used to be looking like this is today fast getting transformed into appearing like this, where, as you see, there is carpet coming in the gangway passage areas to avoid foot tapping noise. There are these clouds on the ceiling front, the square clouds. We have the photocopier machines isolated to the work area with these vertical panels as sound barriers and visual barriers. We have little plants and shrubs behind that you see, which also act as biophilia and to a certain extent provide good amount of sound diffusion and absorption as well. So these are some ways in which spaces are getting quickly transformed. Something was appearing like this traditionally. It could be one of the lounge areas or a common space in your institution. And we see that these spaces are suddenly getting transformed with acoustic considerations to being like these. I'm not sure the visual appeal to you, whether it's really something which is attractive, but the furniture is changing up. There are cloud ceilings, sound absorbing panels coming up. Notice the back wall is also one of the EcoPhone solutions. So that's been printed with a nice photograph image, and that is digitally printed over these panels so that it doesn't affect the acoustic performance of these products. So these are some ways in which the room interior landscape is really changing, and you're actually able to provide better conditions, better working conditions for indoor applications. I think towards the end of my session and the things that I really wanted to present today, I would like to quickly talk about certain solutions that are a part of the Ecophone kitty here in India as well as worldwide. So the website is ecophone.in. It has tremendous amount of information for anyone to browse in detail about a concern that bothers you about acoustics. You can browse through different segments and find out a particular solution that you need for your project. Most of our products cater to a lot of these advantages. So I'm not getting into details of all of that, but apart from superior acoustics, we actually cater to a lot of these functional benefits, right? From thermal insulation to high moisture resistance, green certifications, superior fire protection. So all of these are the key strengths of Ecophone ceilings and wall cladding solutions. The core material, I think we've not discussed about what the products are all together about. So the core material of Ecophone ceilings and walls is to do with glass fibers. So these have high recycled content of more than 70%, very lightweight. So basically glass fibers are compressed and formed into different tile sizes, different structures, different forms. It could be a cloud ceiling or a baffle design or wall paneling system. It's something which is very light and robust, providing excellent acoustic properties and a lot of design possibilities as well. We of course have lots of certifications related to these products. I would not get into too many details in the interest of time, but would just like to talk about two important ones. We have the environmental product declarations, EPDs, listed on our website, which talks about the entire life cycle analysis of our products, right from the manufacturing to the end consumption stage, and the recycling part post the materials come back into the factory. We also have now health product declarations, HPDs, which is talking about the indoor applications and health related aspects. So our products are completely biosoluble in nature, so they do not affect the indoor working environment in terms of any health adverse health effects or health hazards. It's completely safe for indoor applications. And of course, there is no added formaldehyde in the manufacturing process. In terms of VOCs, most of our products cater to French VOC A+ standard. Only one or two I remember are into the A category. Otherwise, all of the others are into the best-in-class performance as far as VOC criteria is concerned. So these are certain benchmarks that we adhere to. Something which is very important to the topic of the day, which I really want to talk and spend a minute more on this, is something called as an Ecophone acoustic calculator. It's a simple predictive tool which is available on our website as a freely available tool. Anybody for that matter can start browsing onto this software, and it gives you all the predictions that you would need to find out for your project. So you can actually check from the drop down menus about the segment wise distribution that is available. So if it's an office or an education or a healthcare, you just need to mention the room dimensions, the choice of furnishings, carpets, no carpets, furniture, doors, number of windows, etc. You just put in some basic information and then you submit it, and automatically it calculates. There is a lot of information which is pre-fed into the software. It calculates all the information and gives you back results on reverberation time, speech clarity, and sound strength. And I'm sure all of us are now well conversant with these terminologies: reverberation, speech clarity, and sound strength as parameters. So it's a very handy tool, really. Something what maybe the HVAC consultants would do or the lighting vendors would do in terms of predicting the lux levels. We have something now to predict the sound levels for your projects. So this is available on our website, which is ecophone.in. I'm just, I think, towards the end of what I really wanted to show today on screen. So these are just few products that I thought would be interesting for all the students to know about our portfolio. This is one of our basic products called Advantage E. It's a 15 mm tile system in 0.9 NRC or Class A sound absorption. It doesn't have wide pinholes. It's a very smooth surface ceiling system. You can easily cut it out for services and incorporate services during installation stages. We have specialized ceilings which are concealed, where you don't see the grid framework. So as you see here on screen, so the same T-grids go inside and the tiles are just laid in a concealed fashion. We have black surface ceilings for theaters, training centers, studios, etc. We've done several projects with Inox, PVR across India. We have an entire range for hygiene, in fact. So Ecophone Hygiene is a product range in itself. There are multiple variants to it for clean room applications and wherever you would need to combine both acoustic solutions as well as high cleanability standards. So we have Ecophone Hygiene as one of the sealing systems. We have clouds under the category called Solo. So Ecophone Solo clouds are in different shapes, colors, patterns, and acoustically, basically the way they work is even sound that goes between two panels can hit the soffit behind and be again absorbed on the back side of the panel. So they are much more efficient and acoustically can create wonders in your projects. And since last 2 years or so, we are actually selling thousands of clouds every year, and it's really catching up as a popular category in India and of course worldwide as well. We also have wall paneling systems with Ecophone, which are high sound absorbers in 40 mm thickness. I'm just running down more images for better clarity and more inspiration to students. So these are clouds and baffles from Ecophone. That's a new introduction called Baffle Wave. It's a phenomenal design which has a wavy pattern, and you can really utilize it for high atriums and larger spaces to create the design effect out of it. And of course, wall paneling for different size, printability, and colors. I thought it'll be great to end my talk with the projects that we've been proud of being associated in India. These are certain brands that we've been serving since almost last decade or so. And these are our proud customers who've been availing Ecophone solutions in India. That's about it, I think. And I think we have few more questions, sir, I guess, and maybe we can take queries from students later.
Yes. Is Prateek available? Because I wanted to get some inputs from him.
Sure.
Yes, Mr. Jana,
Yes,
I'm available.
right. Correct. Now, one interesting question for you. You were among the initial employees of Ecophone. You're trying to push it across India. Now you've come to a country where we know of it as acoustics happens in theaters. Acoustics happens in conference rooms. And they teach you in Europe that it's used everywhere. Okay. So how was that experience changing, and how did you find the market in India, and how do you penetrate this market? How do you teach people about it?
So let me tell you first thing, even 11 years back when we came into India market, even the theaters and auditoriums were not well equipped in terms of the right acoustics. I think, and when we started, every business has its challenges and hiccups and teething issues, and we were not averse to that. So we had our share of some delightful moments. We had our share of some heartburns. We had our challenges. We had internal challenges when we started in 2009, 11 years back. We have external challenges. As you said, the acoustics were only confined to theaters and auditoriums. And there were primarily two major challenges. One is the lack of awareness on acoustics. People were not knowing about the class A absorption, 0.9 NRC, what Manit has been talking about, noise reduction coefficient. There were tiles available in the market which was of low NRC and gypsum boards. They've been using gypsum boards and a POP. So it was a difficult market for us to penetrate. And then immediately we started working on the concept development activities. We got to know the things, if things have to be changed, then we have to actually grow and raise the market, raise the awareness of acoustics. So we got help from our parent company because Ecophone has been doing a lot of research with different universities, and we have published some papers as well. So we brought in all the knowledge what we had from Ecophone. We try and convince our architect friends and designers, and we are successful. From no specifications rolling out about 0.9 NRC to now we have EcoFone specifications coming out. It's a long list of projects which Manit was showing in last 11 years. And we take pride in that, that we have come a long way. The second challenge which we had faced is about the glass wool. So there were apprehensions in the market from our designers and architects and the clients as well sometimes, because the glass wool is a bit hazardous to health. But it is not actually, because EcoFone glass wool panels are high density. What he was showing, it was completely concealed from all the sides, from the paints and the surfaces. We have third-party certifications which claim that EcoFone panels are absolutely safe to use. Oh yes, but then if you're talking about the loose or the low density glass wool panels, which normally use as a infill, and if you use those panels on a wall cladding or for the ceiling, there could be a possibility of the glass wool shedding out, but absolutely no from the EcoFone point of view. Our panels are completely high density, completely concealed from other sides. So it's a long journey for us in last 11 years, and with the support of our parent company and our own team, we started building our own team. I was the first employee, and then Manit joined me a few months later. We started building our team, and now we have our sales reps all across the country. And we have done projects from north to south. We did a school in Mussoorie, which is in Uttarakhand, to south. We have done projects from east to west, all across. We have a technical and a design team to support you. We have concept development team talking about the concept of acoustics in office and education and healthcare, and the marketing team headed by Manit. So it's a long journey for us. But yes, definitely. We had some heartburn, some delightful moments, and I think that's a part of every new setup and new business, and we are with that. So that's it. What was the second question? You were asking something, Mr. Jana. The second question.
Yes, yes. The other part is that once you started approaching people, we wanted to understand who are the stakeholders and who are the decision makers in the process.
So when we started working from the day one, our intention, as I mentioned, our intention is to talk about acoustics and to raise that awareness of acoustics. And then we felt that none could be better than our designer and architect friends. So they are the one who actually write specifications. They are the one who design the interior spaces for which EcoFone panels and the ceilings are required. So the major stakeholders in the project are our architects and designers. But then we have been also working with a lot of knowledgeable acoustic consultants. There are a big set of people who are into acoustic consultancy, and we got to learn a lot of things from them as well. We also approach our clients. We talk about acoustics. Manit is doing a lot of concept development sessions. We have another colleague who talks about the concept of acoustics in education in a different segment. So we approach our clients directly as well. And so we have multiple stakeholders, and we ensure that we reach out to everyone. And now we reaching out to our young and budding architects from your college.
Absolutely. Now, do you actually, like we've invited you and you helped our students learn a bit into acoustics and its applications and how to attend to it? Do you actually run something like this, or is the company aligned to do such training sessions or education bits or something that can help students?
Yes, we have been doing a lot of sessions like this, and we have done a couple of sessions with different architecture schools all across the country. In Chennai, Manit has been doing a couple of sessions. In Mumbai also we have done. And from the day one, it has been our endeavor to talk about acoustics. As I mentioned earlier, we do a lot of knowledge seminars where we invite architects and our clients and project management consultants. We talk about acoustics. We had our speakers coming in from EcoFone. EcoFone globally has been working a lot on acoustics, and we have three different verticals where EcoFone has been working specifically. One is the office vertical, one is healthcare and education, But in India, we have a fourth vertical, which Manit was talking about. It's entertainment. And if you happen to be in any of the cinema halls and multiplexes, PVR, or INOX, or Cinepolis, and watching a nice movie, you would be sitting under, probably sitting under ecophone ceiling with good acoustic environment. So we do a lot of acoustic seminars. We participate in exhibitions. We do these knowledge-based activities. We do concept development activities, one-to-one with our clients. And that's a part of our system from the day one. It is not only in ecophone. I think it's a global practice from. It is not only in ecophone India. It's a global practice from ecophone Central and all across the globe. We have been working very closely with acoustic consultants, with our architect friends, and we do a lot of knowledge seminars for them, telling them about not only about acoustics, but then we also brief them about the new product launches, because now it's a feeling of pride, because we have come a long way. So when we started our business in India, we had a couple of very few items to be sold in the market. But now, so whenever there's a new launch, and every year we have new product launches, it is on the real-time basis. So if there's a launch across Europe, in North America, the same day, it's a real time, we are launching the same products into the market. We sell the same products in Indian market. What I've been selling in Europe and America. So we do a lot of marketing activities. We are also involved in social media activities, bringing awareness on acoustics.
Yes, one of the faculty members, Neha, had a question. Neha, just go ahead.
Yeah.
Yeah.
I had one question that does Saint-Gobain have any products that can be applied outdoors in terms of building facades to absorb traffic, or to to lessen the traffic noises in public areas and public spaces?
Okay, Saint-Gobain, if you talk about Saint-Gobain Ecophone, we have the products which are for interior spaces. So unfortunately, we haven't developed anything which is for the exterior area. So we don't have anything, but to arrest sound or noise within the four walls of the room, we have the product. But for the exterior application, we don't have, Ecophone does not have anything which can actually cut down the noise coming from the street to inside the building. But I'm sure there are other companies and other vendors who can provide you some glass windows, and which can actually cut down the noise. In fact, our glass business, Saint-Gobain has a glass business as well. And they're also developing something on the same lines, which can actually cut down the noise. It's an exterior application, cutting down the noise from the streets to inside. But Ecophone does not have anything for exterior applications. Everything is all about the interior application.
Thank you.
Yeah. One more thing is, what would be your advice to students at Navratna University? Like, suppose they wanted to learn further about this, or how would they go about this, or where could they find directions? What would your advice be to them?
So I think we have been talking about acoustics for the last 1 hour. We are talking about sound, noise hazards. So I think we do, as I mentioned earlier, we do a lot of these sessions. Manit has been doing a lot of these sessions with different universities and colleges, talking about acoustics to architecture students starting from third year to the final students. And we can also have a session in case, these are difficult and different times, So probably if things would have been normal, we would have been sitting here with you in Baroda and talking to the students physically. So this could have been different experience. So probably when things slightly become moving toward the positive side, we can have another session with you, maybe virtual online session, or the physical sessions, where we would be talking a lot in detail, because this is just 1 hour session and we have to rush through everything. There's a lot to understand from acoustic point of view. So acoustics, it's primarily, it's the physics. It's not a rocket science, but then the application and the usage of acoustics required some expertise. We can do another session, and there are a couple of YouTube videos available from Ecophone Television. So it's Ecophone TV. They can log into that. They can get into ecophone.in. There's a lot of information about acoustics, a lot of frequently asked questions. And in case if they further need to know anything, they can obviously connect with us, connect with me, and connect with Manit. And I'm sure in soon and near future, we would be working with these smart and upcoming architects for our business.
Absolutely. Our Dean Pratyush has a question for you. Pratyush, please.
Thanks, Manit, and thanks, Prateek, for this really wonderful lecture. I think it's very nice that, Manit, how you kind of clarified on some key concepts in a very simple fashion. And actually, you did that by playing sound files, which is something that is so nice because it kind of hits you directly. And I really appreciate how you introduce some key concepts. And I have a much more broad-based question than the specific ones. And thanks for introducing your company and the kind of journey that your company has taken. And I was just wondering, now you might call it a more philosophical question, but I was just wondering that first question was that your products, who designs these products? There must be a design center, research center. And I'm just wondering, because the people designing these products would have a very good understanding of the scientific basis of the products, their strengths, durability. But they would also have a very strong aesthetical perspective, or maybe they work in teams because their products are going to decide the nature of interior space that also comes. So I was very curious about product development itself. So that's first part of the question. And that's a real interest to me because I don't really, of course, we want our students to use your products, but we also want our students to develop products and lead in the way you visualize these things. And the second question is, I'm just wondering, whereas the solutions that you have shown today assumes that there is already an enclosure and you're trying to retrofit that enclosure, or you're trying to make it nicer acoustically speaking. I'm just wondering if we start with materials that are inherently have certain acoustical possibility. Now, this is more as what kind of architecture can it lead to? So what kind of architectural typologies are supportive of what kind of, acoustical behavior? And that's a larger question for maybe a design competition that we can organize and have it as one of our juries or something. But so I just wanted some, clarity or some.
Can I take that?
Yeah. Oh, yes, sure.
Okay. So I think as far as the first question that you put forward, the R&D teams in Ecophone in Sweden are extremely active and quite involved in new researches, and that's actually the philosophy with Saint-Gobain as a group as well. So although we are, so to say, 350 years old now across the globe, but it's that old an organization as a matter of fact, but it's still extremely young and dynamic because we have tremendous amount of innovations that happen every time. So specifically related to acoustics, I would like to say that this also was actually a part of a large experiment, and by accident, this whole setup came into being during 1958. I'm talking about more than 60 years ago. And gradually, the entire setup actually started evolving in such a way that we have always found and placed our bets on glass wool as a core material, being a very efficient sound absorber. And there could have been cases that with the R&D huge team in place, they might have come across many other types of materials which could be better sound absorbing materials, or at least to an extent providing sound absorption as a property. But the fact really remains that till date we have always had our best bets and our faith in glass wool as a core material, because of some fundamental reasons, that it's extremely porous when it is manufactured in fibers and then compressed together. It's extremely light in weight and very easy to manage at site logistically. So there are certain clear advantages that we have always been working with. But at the same time, I would say that there is a huge scope of innovations. Like, for example, what I think ma'am had put forward a question that what about the exterior noise control aspects? So I'm sure there are lots of research works which are happening parallelly to ensure that we bring in products which are also suitable for outdoor applications. But at the same time, since we've been having these sessions, across many architectural institutions, one question which often comes up, and I'm assuming that's also something which was related to what you asked, is about using naturally available materials. That is something which often students tend to put forward as a question. So, things like jute-based material or something which has high porosity, like even for instance, wooden paneling, which is often a part of large auditoriums, etc. Now, having a wooden paneling itself is not going to give you good acoustics. But then if you are able to create lots of perforations, punctures, have lots of absorptive material placed behind that, then is when it can actually start giving you at least close to class C or class B performance. It's only then you will be able to achieve certain degree of sound absorption out of it. Now, obviously, if right in the first instance, the choice is to go for a higher sound absorbing material, like a class A based systems, we would continue to recommend only a glass wool based material, because there is actually nothing else which gives you as high sound absorption as maybe a glass wool would do. And especially from, I missed out the second question that you said.
No, I was not. I mean, you are really nearly there about the second question. I was just wondering, like, for example, I'm not only referring to, let's say, using mud or using wood, but I'm also referring to certain kind of configurations, right? Because sound is also the function of the geometry of the space.
Yeah, I recollect that now.
Floating roof, low walls, and ventilators on top is naturally easy to deal with. So I have to then put less energy in trying to retrofit.
Absolutely.
What I'm also wondering is, are there some natural spatial typologies that allow for certain kind of acoustic behavior or disallow other kinds of behavior? And that would be very interesting for an architect to visualize, rather than only look at a problem from the perspective of introducing surfaces.
Mm-hmm.
I'm just thinking aloud.
I get your point. Yeah. In fact, two interesting examples come to my mind. There's a concept called tilting walls. I'm not sure if many have heard about it. In fact, in India, we have come across some buildings which have been designed. Maybe acoustics was not the only reason why they were made that way. Correct. But what we get to understand is, architecturally, if you're able to tilt the wall either to an inner angle or an outer angle, it doesn't matter. But what essentially we're trying to do is we are avoiding a parallel reflection of sound there.
Absolutely.
And the moment it is tilted, sound wave hits it and is again going towards the upper side. And if you have an acoustic ceiling there in place in that office or in that space, there are higher chances that you will get much better acoustic results than having parallel walls together.
Correct.
In fact, another example is, for instance, even if you talk about retrofitting it, there's sometimes a question that when we have a large boardroom or a conference room, we need to do wall paneling there. Say an Ecophone wall panel needs to be put up there. So what are the choices available in hand? Should it be two opposite walls or all four walls, three walls? What's the best way to deal with that? So architecturally, again, it makes a lot of sense maybe to have an L cladding, two adjacent walls being cladded with the wall absorber rather than two opposites. Because when you clad two opposite walls, there are the other two walls which will still have the parallel flutter there going on. But if you do an L cladding or an adjacent wall cladding there is at least one wall which is taking away that excess sound. So architecturally, there are some ways we can definitely do so. So we always talk about this, that instead of designing perfect squares and rectangles, it's good to tilt the walls to certain degrees and certain angles, and you can really create wonders out of it. But of course, if you are not in a position to do that, you can always fall back on Ecophone.
That's a nice sales pitch.
I guess your first part of the question was also about the design and aesthetics you were asking about.
Yeah, Prateek, what were you saying?
I was saying the first part of the question was also about some aesthetic and the designs along with the acoustics?
Because I think like your team in Sweden, and I'm just wondering what kind of profile they are. Are they product designers? Are they engineers? Do they work in teams of product designers and product designers and architects and interior designers? Because the products they produce not only solve the sound problems, but they have a lot of impact on the look and feel of the space.
Absolutely.
Millions of square feet where your product is applied. So in that sense, they hold a lot of power. And I was just curious to know more about that work environment.
Okay.
Because as I believe that we would aspire that our students are not, of course, they use these products, but they also kind of get into the research of these products. And some are very curious kinds. They want to do all that.
Correct. So let me explain to you. Primarily, we have 4 different categories of products. One is the ceiling systems, suspended ceiling system. It comes in different sizes and thicknesses and the edges. Second is the wall cladding or the wall panel. Then we have these free hanging units. We call them solos. And then we have the ceilings which can be directly glued or fixed on to the soffit. So we have different product managers for different categories of these products. And these are the families in themselves. So we'll talk about the suspended ceiling systems. There are multiple products in that with multiple edges and multiple surfaces. So we have product manager who have been working on the design part of those ceilings. And so as I mentioned in my discussion, that every year we have new product launches. So it's a part of our product portfolio. It's a combination of aesthetics and the performance, which we are focusing on. Secondly, we also have an acoustic consultant on board in Ecophone who does a lot of research internally, goes out and start working with the different universities and get a lot of inputs from different acoustic consultants. He himself is an acoustic consultant. He has been on part of the Ecophone for many, many years. So this acoustic team, along with the product development team, they work on the products which can be aesthetically, as you mentioned, looks beautiful, and as well as on the other side gives a very high sound absorption performance. So it's a combination of both that has been working well with Ecophone, and with that we have ample amount of n number of products which we have in our portfolio with different sizes and shapes and different colors. We do a lot of research work on aesthetics as well. Manit was showing you some latest products. We have these the blades, we call them baffles, and earlier we used to have the flat baffles. Now we have baffles in a wave form. So we did a project in Mumbai in one of the IT companies for their large cafeteria. It was done with our solo baffles in the wave shape and looks beautiful. So this has been part of our Ecophone central innovation and the product development team along with acoustics that works together.
Thank you.
Yes, Fakhruddin, you had a question.
Yeah, hello, sir.
Hello.
Thank you, sir, for first of all for giving me and for sharing us the knowledge and experience you had in this field of acoustic. I would like to ask Manit, sir, that how to calculate the distance between the source of a sound and what would be the distance between the source of a sound and the acoustic panel, because there are varies in a sound frequency and there is in between the capacity of an acoustic panel. So is there in formula, because there is varies of a size, of course, because sometimes as an architect we also work, we need for an theater, and sometimes as an architect we have to work for office room. So what would be the ideal distance in that case? Is there any formula or something?
Manit?
I think Manit is.
Manit, are you available? Are you there?
I think he just lost his connection.
Okay.
Just one. Manit is back. Good.
I think, and then you have to repeat the question to him.
Yeah.
Yeah. So, Manit sir, what my question is that what would be the ideal distance between the source of a sound, the acoustic panel? Because we work in a very different sizes. Sometimes as an architect, we used to work for a theater, and sometimes we used to work for a cabin, for a very small cabin. So according to you, what is the formula to calculate the distance, the source of a sound and the acoustic capacity? Or so that's what I ask.
I'm so sorry. There was sudden disruption of internet. I have just switched to another room.
Yeah.
Can you let me know the question once again, please?
Yeah.
I'm so sorry for
no.
Yeah.
What I'm trying to say is that what would be the formula to understand the distance between the source of a sound and the acoustic? What would be the distance, ideal distance for that? Because there are frequency for a sound, there are different capacity of a acoustic panel to absorb this. And as an architect, we used to work for sometimes for a theater and sometimes for a very office room. So, according to you, what would be the ideal distance or in between? So it works in a very good, in a very efficient way.
Yeah. So often, it's actually to do with, as we mentioned earlier, the room dimensions. What are the possibilities of cladding different surfaces, whether it's ceiling or walls, whether it's one wall or multiple walls? Because depending upon the product properties and the kind of activity that is going to happen in that room, you would need to actually figure out what is the best material available in hand and what is the absorption capacity of it. So basis that, you will be able to determine and choose the best product to be applied in that space.
Yeah. Do we have any kind of software or something which helps us to gauge the distance?
Not really for the distance part, but most products, like also in Ecophone, they are tested for a certain, say for example, the ODS or the overall depth of system that we discussed. So what should be the distance between the slab and the fall ceiling? So there is certain distance in which these lab tests are done. If it's wall paneling, what is the air gap that we put behind? So these are certain parameters which are already considered during the product testing stage, and they are designed towards these interior applications.
Yeah. Okay. Yeah. Understood. Thank you, sir. Thank you.
There is a software which is
Yes, sir.
available with us. It's on our web page, as he has mentioned earlier. And there are different permutation combinations. You have to put in the area, the specific area. It has got office spaces. It has got different spaces where you can choose, and then choose the material. It will probably give you some idea on the acoustic performance of the ceilings. So that's a software which is available on our web page.
Yeah.
If you log into www.ecophone.in. It's a combination of
Yeah. Thank you,
products
sir.
and specific areas.
Ji.
Any other questions? Not that I see. So I'd like to conclude this session with a vote of thanks for Manit and Prateek for making time, for giving us all this valuable information and spending this time with us. Thank you, Manit.
Thank you so much, Mr. Jana. It's been a pleasure with all of you. Thank you so much for inviting us.
And we look forward to associating. If you have any questions or we require some technical support or anything, we will always get back to you.
Absolutely, most welcome anytime, sir. Thank you much. Bye-bye.
Thank you very much, and do not forget to consider acoustics.
Yes.
Thank you. Bye-bye.
Bye-bye.